All right, let's get started. Again, welcome to everyone who's joined us today. I'm Samantha Link, and I'll be moderating today's webinar on robotic inspections for small diameter piping. As we go through the presentation, all attendees will be muted, but please be sure to send in questions to the Q&A feature located on the bottom of your Zoom webinar screen. I'd like to go ahead and introduce our presenter today, David Vatz. David is the Pulp and Paper Industry Manager at Gecko Robotics and has been in the pulp and paper industry for the past couple of years. He's become a huge proponent in helping mills understand robotic capabilities in the industrial space, as well as data utilizations for inspections. Let's all welcome David.
Hi, everybody. Sam, thanks very much. Appreciate the introduction. As Sam mentioned, my name is David Vatz. I'm the Pulp and Paper Industry Manager for Gecko Robotics. But I did want to let everybody know that during this presentation, we're going to be talking about robotic applications for inspections on small diameter piping in a variety of industries, including the pulp and paper industry, oil and gas and chemical industry, and also the power industry. So as Sam mentioned, as we go along here, feel free to put any questions that you have in the chat, and Sam will interrupt me throughout to ask questions as we go along here. And then also we'll have some additional time at the end for more questions. So I wanted to start here by just talking a little bit about what we're going to go over today during this presentation. First, I wanted to just note what we're going to consider small diameter piping for the purpose of this webinar. So we'll talk about piping that ranges from primarily 4 inches and up, although we will also talk about some potential future developments for piping that's maybe down to as small as 2 inches. We'll start off by talking about some of the manual methods that some of you might be familiar with for inspecting piping circuits. We'll also talk about some of the risks that you might experience from using those typical manual methods for inspecting piping. From there, we'll go into some of the automated methods for inspecting piping, so robotics, including AUT, phased array, and rug. And then we'll discuss a little bit about how you can utilize automated data, rug data, AUT data, phased array data in order to improve your piping inspection programs. And then finally, we'll talk a little bit about the future, new developments in robotics and how that's going to enhance these methods going forward. So the first thing I wanted to talk a little bit about is the manual methods of inspecting piping circuits. And these might be methods that you're familiar with or not, but primarily what we see when we go to mills and oil and gas facilities and power plants right now is that most are using a manual UT and visual inspection for their piping circuits. So a typical manual inspection would be one of 2 things usually. It could be a sampling method. And so what you see on the right here is a typical sampling method that was used on a digester blow line. And in this, what they were doing is each foot of the digester blow line, they were taking readings at 4 points around the circumference of the pipe. In addition to just a more broad sampling method, you could also do what we would call manual ultrasonic gridding. And with manual gridding, what you would do is you would set up a grid at some predefined distance, for example, 3 inch by 3 inch, 6 inch by 6 inch, 12 inch by 12 inch. And you would take readings around the entire surface of the pipe on that grid. So in each 3 inch by 3 inch grid, for example, you would take 1 UT reading. One of the challenges with both of these methods, in particular manual gridding, is that it's a very, very slow process. So in order to get a lot of data, it takes a lot of time for the inspectors to do so. In addition to the amount of time that these manual methods take, there are a lot of risks that you could encounter with these manual methods. First of those being just the safety of the inspectors in general. Manual methods and piping circuits in general tend to be high up off the ground, sometimes twisting and turning in different locations. And so in order for manual inspectors to access those piping circuits, they're often going to have to use potentially dangerous methods such as rope access, You're gonna have to build a lot of scaffolding for it. And then these pipes, when they're in operation, can often be at high temperatures and contain hazardous contents, all of which will put the inspectors at risk when they're performing those manual inspections. In addition to that, using manual methods to inspect piping creates potential safety risks for the ongoing operation of those piping circuits. If you're only taking a sampling of data along the course of the piping, there's a decent chance that you're going to be missing out on what could be large damage mechanisms or areas of wear that you're not able to find with just a simple sampling method. As I'm sure most of you know, piping can have often greatly varying conditions across the surface of the pipe. If you have a 100 or 200 foot piping run, you might have very different conditions on one end versus the other. And you're also going to potentially have different conditions in different bends and turns that the pipe makes. And so if you don't have a good sense for what areas are experiencing wear because you're only taking a sampling of data from various points, it's going to be difficult to understand what areas you should and shouldn't repair. And this could lead to a few different problems. First of all, if you repair too little, you could be experiencing potential safety hazards where you have piping that has corrosion or that has damage mechanisms that you weren't able to find. And that could put the operations staff at risk because of that. Or you could be repairing too much, in which case you're spending more money than you need to and potentially taking assets out of service for longer than you need to in order to make those repairs. So in order to improve this process, there's been a large influx of more automated approaches to collecting NDT data on piping circuits. And the first two that we'll talk about are automated UT or AUT and phased array. Both of these methods have a significant advantage over manual NDT in that they're able to gather bulk data on the piping. They're gathering continuous UT readings across the course of the piping circuit, as opposed to just point readings at specific places. Because of that, you're gathering extremely high resolution data that's going to allow you to understand better certain types of damage mechanisms that might not be obvious with traditional UT. So you're going to be able to understand things like generalized corrosion and wear, but you can also profile other damage mechanisms such as pitting or defects within metallurgical structures. And these approaches currently can go all the way down to about 4 inches OD for gathering data. Now, that being said, one of the disadvantages of these methods is that they do tend to take a long time. So it might take many days or even weeks to perform AUT or phased array on an entire piping circuit. And because they do take such a long time to gather all this data, they can be cost prohibitive when you're looking to perform an inspection on a large area or a full circuit of piping. So here's a video of AUT in action so that you can see what this looks like on a piping run. And as you can see, you have the transducer going back and forth, collecting readings along the surface of the pipe here. And in fact, on the left side, you're seeing it operating in one direction. On the right side, you're seeing it operating in another direction, although it's performing the same scan in both cases. But down at the bottom left here, what you can see are these actual readings coming through the system. And you can notice in particular, right here at the bottom, an area that we would consider something like pitting that would be very difficult to determine with traditional manual NDT, because if you're just performing sampling readings around the circumference, for example, you really have to hope that you're going to hit those areas that actually have the pitting in order to collect those readings. And then this here is an example of phased array being utilized. With phased array, It's going to be a similar concept to what you would see with AUT, the difference being that it's going to be a little bit higher resolution. And once again, you can see here we're picking up some of these underside defects that would be very difficult to ascertain with manual NDT. The third method that I wanted to talk through is what's called rapid ultrasonic gridding. And so what you see here on the right side is the Gecko Robotics robot. And up at the front here, you can see the UT transducers. And what rapid ultrasonic gridding does is it performs a grid UT pattern, but it does it extremely fast as compared with manual NDT. So rapid ultrasonic gridding is an extremely fast method that can be you can cover, for example, on a piping circuit up to hundreds of feet per day, as opposed to with something like AUT or phased array, which is going to be more targeted and is going to take much longer to collect that information. Because of that, it ends up being much more cost effective than the other automated UT methods, while still gathering really high resolution data. So with rapid ultrasonic gridding, you can gather data that goes down to about 1/4 inch by 1/4 inch resolution. So it will still allow you to identify things like underside pitting and other damage mechanisms like that that you would otherwise not be able to identify with manual UT. It also is a much safer method than manual methods because most inspections can be performed with minimal or no scaffolding and also without rope access. So the robot that you're looking at right here, it uses magnetic wheels. It can hook up to any ferromagnetic surface, and it can perform a scan oftentimes without any additional infrastructure added. Now, that being said, rapid ultrasonic gridding is not going to be as high resolution as something like phased array or AUT. So it will be slightly lower resolution. But that being said, the way to use RUG is as a quantitative screening tool. So you can take a RUG robot like the one you're seeing here, and you can run it on an entire piping circuit that's hundreds of feet long. And then based on the data that you get back from that screening, you can then do the more expensive, slower, ultra high density methods like phased array or AUT, just on areas where you think a deeper dive is necessary. So rather than using the very expensive method on everything, you can use a faster, lower cost method to still gather bulk data such as RUG, and then go back with the more expensive methods for just the areas of concern.
So David, there's a few questions in here. First one is that, scaffolding tends to be a pretty large amount of the cost of inspecting assets. Can robots really inspect all of these assets without scaffolding or rope access?
Yeah, it's a good question. There's not really one easy answer to that. Most of the time, we are able to reduce significantly or eliminate the amount of scaffolding or rope access that is needed to perform an inspection by using RUG as opposed to manual methods. That being said, depending on the specific access conditions for a piping circuit, there might still be certain areas where either a JLG is necessary to reach certain areas or a limited amount of scaffolding. But we can often reduce the amount of scaffolding or reduce the amount of rope access by a significant amount, which can often save a lot of money and a lot of time just on those infrastructure costs, while also making the entire inspection a lot safer.
Great. So what's the best application for RUG versus AUT and then vice versa?
Yeah, it's a good question. What we were talking about before with RUG is that RUG is going to be much faster. So it's going to be a fast way to quantitatively screen an entire piping circuit. So you could scan an entire piping circuit with RUG in, say, 2 or 3 days that might take AUT 30 days. And based on the data that you get from RUG, you could then go back to the areas that you noticed significant wear or maybe certain damage mechanisms like pitting, and you could spend a day or two doing AUT just on those areas. So it makes for a much more efficient and cost-effective inspection. So, really the way to look at it is RUG can give you that high resolution data on the entire asset, whereas AUT or phased array can be used in specific areas where you have greater concern to gather extremely ultra high density data on just those areas.
Great. And so what if there's external corrosion on a pipe? Does it need to be buffed off?
Not usually. The robot, for the RUG robot at least, that Gecko Robotics provides, we can often perform scans on surfaces that are rough or that have a mild amount of external corrosion. I mean, there's always going to be a limitation of that. If it's really, really bad, it's possible there might need to be some cleaning or sandblasting done beforehand. But the majority of inspections that we do, the vast majority, I should say, are done without any additional cleaning and certainly without any buffing that you would normally see with manual UT. Oftentimes you see the guys out there with wire wheels, scraping off things. That's not something that we typically have to do with our robot.
Great. And then just a couple more here. So have you used this technique for wet H2S examinations?
I don't believe we have. It's something we could certainly explore. If it's something that you're interested in getting more information about like that, the best thing to do would be to contact me after the webinar. My contact information will be here at the end, and we could talk about exactly what the challenges with something like that would be.
Great. And then with RUG, are you getting a 3-digit readout or analyzing signal data?
We are analyzing actual signal data. So while we're performing an inspection, we are collecting the raw A scans, and then our software is going in and analyzing that signal data along with some human touch, where we have trained level 2 NDT inspectors who are going through and looking at signals that were harder for the computer to interpret. So we are not just doing 3-digit thickness readings. We were actually collecting the signals, which allows us to do much more advanced things, like we can identify coating thicknesses. We can identify when something is a true back wall reflection with the actual A scan that way.
And then one more just came through. Can RUG do insulated pipe?
Yeah, good question. The answer would be no, it cannot do insulated pipe unless you remove the insulation. So, anything that you can't take a UT reading on that's insulated, with a manual meter, you probably can't do RUG on. So typically with insulation, you would need to remove that first. If it's something like a coating, like paint or even epoxy coatings, we can usually perform the inspection without having to without having any issues with coatings like that. But with insulation, foam, things like that nature, that would disrupt the UT signal, and so we wouldn't be able to take readings without removing that first.
Great.
All right. I guess. Yep. We'll keep rolling forward here. What you see on the screen right now, this is a RUG robot. These are robots that are used in inspections and these were developed by Gecko Robotics. So what you can see up front here, these are the UT sensors, the UT transducers. And then the wheels back here that you can see, these are permanent magnetic wheels. And so these robots can cling to any surface that is ferromagnetic. That includes carbon steel piping, but it also does include things like 2205 duplex or overlaid carbon steel piping. And here's a quick video of the robot in action. This is on a blow line. You can see we're handling a very hot asset here. These can get up to about 300 degrees when they're in operation. And the robot itself is going to move at about 1 foot per second. So that's how we're able to scan such a large area in a short period of time.
So what were to happen if the power were to cut off to the crawler? And then are there any risks there?
Yeah, good question. Since the robot itself uses permanent magnetic wheels, there's no risk if the power shuts off. It's something that we do see a lot of, especially working during turnarounds and outages, shutdowns, things like that. The robot will just stay where it is if the power shuts down, and it'll wait until we get the power back to it in order to move it back down. So unlike what you might see with some other climbing robots, our robot has never fallen off a wall, it's never fallen off a pipe, it's never fallen off a tank. It's got magnets that can hold about 10 times the weight of the robot.
And then
the wheels.
what's the temperature limitation on rug systems?
Yeah, for an in-service inspection, right now we can go up to 250 degrees Fahrenheit. The typical ambient temperatures are no problem, obviously, but then anything above 250, we would need probably to perform that inspection while the asset is out of service. Or for something like blow lines, for example, like with blow lines at a paper mill, you're going to see those often spiking over 300 degrees during an active blowdown cycle. But after that, they tend to go down below that 250 mark. So we would just need to pause the inspection while the temperature goes up beyond that 250 and then continue inspecting once it goes back down. The robot itself is not going to get damaged by those higher temperatures. It's just going to be harder to get readings once you go above that 250. All right. So now that we've talked about how to collect all of this data with RUG, with AUT, with phased array, the question then becomes, how can you utilize that high resolution data to make better decisions on your inspections? And so one of the most important things that you can do with this data is you can use this high resolution data to make better decisions about what you should be inspecting. And that goes for two different things here. One would be understanding areas where you might need to focus your inspection. So you might need to do a deeper dive into a specific area. Maybe you perform RUG on an entire piping section, but then you do AUT on just a small area where you saw a lot of wear. And then it also allows you to focus future inspections onto the areas where you're seeing the most degradation in the integrity of the asset. So rather than performing a full inspection every year or every 3 years or every 5 years, whatever interval you typically go with, maybe you would only perform an inspection on a small area of it every year and then do a full inspection every 5 years. So this will allow you to better understand the quality of your asset and the current situation with your asset, which will then allow you to make better decisions on what to inspect going forward. Now, in addition to that, using this really high resolution data will allow you to do a better job of making more targeted repairs. And a good example of this was a oil and gas customer that we had who had a large section of piping that they were planning on replacing at a cost of about $200,000. They brought us in to perform RUG on that to get a better sense of the overall situation with that piping. And based on what we gathered for them, they were able to focus their repair on just a small area that had significant wear and save about $175,000 in the process by doing a much more targeted repair. All of this will allow you to greatly improve the safety both for your inspectors and then also for your operations, because if you're repairing the right portions of your piping as opposed to doing larger repairs or repairs that are too small, you're going to have a much safer operation and a more cost-effective operation. And so here's an example of what RUG data actually looks like. This is for a small section of piping. So you can see this is just a group of UT readings. And then also you can view this in 3D. So this is through the Gecko portal software. You can view the entire piping run in 3D. You can view the pictures associated with it. And you can view all the UT readings that were captured as part of the RUG inspection.
So how is the data visualized from AUT and phased array robots?
Yeah, it's going to be the same concept of what you're seeing with RUG data visualization. So, you've really got three things that you're looking at. You've got A scans, which are the which are the actual sound waves that we collected. You've got B scans, and then you've got C scans, which is what you're looking at right here, which is going to be an aggregate of all of that data shown in context of the asset. So with phased array, with AUT, and with RUG, you really have those same three things that you'd be dealing with. All right. Lots of applications for robotic NDT that occur throughout a variety of different types of facilities. So everything like in a paper mill, from blow lines and white liquor lines. In oil and gas facilities, we've got crude lines and flare lines, natural gas lines, all the way to things like coal piping at power plants. Any asset that you have that is ferromagnetic, we can, and 4 inches and up, we can stick our robot to and we can perform an inspection on. All right, and we'll walk through a quick case study here on some blow lines at a paper mill. For this one, what you're seeing here and what you're seeing in the video, this is our robot crawling on an 8-inch carbon steel line that goes into 10-inch headers. Right here, you can see it climbing on the elbow that comes out of the digester. These can be particularly challenging assets to inspect, as I'm sure many of you from the paper side of things know. They're very hot. They can get up to over 300 degrees during operation. And there's a lot of obstructions, a lot of twists and turns and elbows that have to be contended with along the way. So what I'm going to do here is actually pop out of the presentation. I'll show everybody a quick view of what the data actually looks like coming out from RUG. So this is an example of digester blow lines that we inspected. This particular example is about 40 feet of digester blow line. And you can see some interesting things and get some insights from just looking at this data right off the bat. First of all, you can see that this area that goes to about 15 feet is an area of much higher corrosion, much higher wear than the rest of it. And so that could be due to a previous replacement, or more than likely what it's due to is the fact that this area right here is actually an elbow that comes off of the digester. And so what we would expect to see with something like this is that you would most likely see the greatest amount of wear on the outside of the elbow. And so that's what we see right here at this middle point. And you can see we've got these range filters, so we can actually drill down and look for just the highest wear areas. So if we're looking to make a replacement or a repair on this piping, we can focus on just the area that actually needs it. And then here's another example of a crude line. And this is the 3D version. And so you can see we can visualize everything both in 2 dimensions and in 3 dimensions. You can move around it. You can even go inside the pipe and see exactly what's happening inside of it along the distance of that piping circuit. So there's lots of great things that you can do by having this bulk data. It really opens up the possibilities of the visualizations that you can have on your data to give you a better understanding of exactly what's going on within the asset.
So David, people want to know, how big is the robot that was inspecting that blow line? And then, what's the size range of the robotic devices and how much spacing do they tend to require to function?
Yeah, so the one that you saw in the blow line, and I'll just back up here a couple slides if I can. That one goes, so it sits about 6 inches off of the pipe itself. This is on an 8-inch carbon steel line. Now, this robot can also perform inspections on everything down to 6-inch lines. And then with the AUT and phased array, we can go down to about 4-inch lines. And that actually segues, Sam, I don't know, is there another question, or because that segues pretty well into this next slide talking about the future.
The only other question is primarily about the data so far. So. Okay.
All right. Well, so I'll talk through just, how that segues in here. There's going to be a lot of future development in miniaturizing this technology. and getting to the point where we can inspect things like 2-inch piping as well. Right now, it's about 4-inch piping that we can inspect. But just in the last couple of years, there's been huge improvements made in what piping can be inspected with robots. So just 2 years ago, Gecko Robotics could inspect piping that was about 24 inches outside diameter. Today, we can go all the way down to 4 inches. So huge improvement just in 2 years. Robotics, of course, is a field that's growing very rapidly and changing very rapidly. And so I just wanted to show you also, this is actually a video that's from a different company's robot, but it's a great example of some of the potential advancements in the future for robotics. So this is a robot that's climbing through the ID of a pipe. This one would be a 2-inch pipe that it's climbing through. This robot currently only does visual inspection, but just a great example of what's to come in the future here with robotics. But really what RUG is able to do and where we see this going in the future is that it truly opens the door to digitizing entire piping circuits, to creating those digital twins that are becoming so important throughout the industry right now. It allows you to essentially nail down the entire state of your piping circuit. And so what you see here, this is the Gecko Robotics platform also, and this kind of shows you that concept of a digital twin of your facility where you can actually drill down into a specific asset and you can see what the condition of that asset is at a glance. So robotics in general, RUG, AUT, phased array, are leading the way to help get you to this future state where you have a true digital understanding of everything that's happening inside of your piping circuit. All right, well, that's all I have for today. I appreciate everybody's time. And as we mentioned at the beginning, if you have questions that you'd like me to answer, I will stay here as long as needed to answer whatever questions you have. All you need to do is go up to the chat function, the Q&A function, and type in your question, and we would be happy to answer it.
Great, thanks, David. So let's go ahead and get started with some of the questions that are already in. So first one here, does the software allow quick comparison of current data versus historic to quickly assess progression of defects?
Yeah, absolutely. That's a great question. One of the good things about robotics is that it's going to perform the inspection the same way every time you perform the inspection. It's always going to do things in the exact same way. And that allows us to do trending analysis that can be very accurate over time. And so the software that I showed you previously, that can do year-over-year trending analysis. It can do projections into the future, regressions on certain areas. So you can see, for example, how many years you have before you reach your minimum thickness, your code thickness, where you would need to perform a replacement or a repair. So the software and the RUG data that you gather will help you to do that. And it will allow you to, instead of just doing it at specific points along a piping circuit, you can do it over the entire distance of the piping circuit. And the software itself can even do things like visualize what the pipe looks like today, and then also what it's going to look like next year, 3 years, 5 years in the future, so that you can get a good visual understanding of exactly what's going to happen over time.
Great. And so just it looks like some clarification here. They want to know if the RUG systems can go down to 6-inch or 4-inch nominal pipe size.
The RUG system that was developed by Gecko Robotics can go down to 6 inches right now, with more expected in the future. But the phased array and AUT can go down to 4 inches right now. And so, at the moment with these robotic methods, we can get down to that 4-inch piping. With RUG, we can get down to 6 inches at the moment. Great.
And as far as spacing requirements, how much clearance would you need to scan a 10-inch diameter pipe using RUG?
Yeah, it's a good question. For a 10-inch piping, it was similar to what we saw on a previous slide with the blow lines. You'd be talking about 6 inches of clearance above the robot. And so what that would primarily mean is that if there are areas where we don't have that 6 inches of clearance, it just means that you need to move the robot above or below that area in order to continue scanning. And then we can fill in areas that were missed with the rug with manual UT in order to get you a full picture of the data. But with robotic scans, as compared with manual, oftentimes you have to kind of go through and do a little bit of pre-planning to understand where those areas of concern might be and where there might be clearance issues. And that's something that we do every day. This is what we do whenever we perform a piping scan is we will evaluate what areas there might be clearance issues and how to attack the full piping circuit and be able to get data on the entire piping circuit.
Let's see. So all of the data, is it maintained by Gecko and only online?
Yeah, it is maintained by Gecko, but it is not only available online. You can always download the data to have it through an Excel sheet. If you want to upload it into a different system, you can do that as well. So it is your data. You can always grab it and use it for whatever purposes you need. But Gecko will continue maintaining it on the online portal, which will be available to you and then any other users that you would want to add to that data. So a little bit of both, I would say, is the answer to that.
Great. Are there any specific challenges to manually inspecting small diameter versus large diameter piping that robots can uniquely handle?
Yeah, I mean, with all of it, primarily what you're able to do with robotic inspections that you're not able to do with manual inspections is to gather that bulk data. And so robots are uniquely positioned to be able to perform these inspections much more quickly than manual inspection while gathering orders of magnitude more data. So you're talking maybe 100 times more data. So in particular, for piping circuits where you might have corrosion issues, where you might have pitting issues, using a robotic solution for that is one of the only ways to truly find some of this ID pitting, for example. You might not be able to find that with manual inspection. So what it really comes down to is being able to gather that bulk data is going to be hugely beneficial in a lot of applications. And that can include small diameter piping and large diameter piping. It's going to be beneficial for both of these. And so the primary thing is being able to gather that data to allow you to make better decisions, to allow you to better understand exactly what's happening within the piping circuit.
Great. And then real quick, somebody would like to see the phased array video again briefly.
Okay. Yeah, let me just back up to that one. Happy to show it again. And I believe also there will be a recording of this available that will be sent out to all of you. So everyone will be able to watch it again. This is farther back than I thought. I think we got it now. Here we go. Yep, let me press play on this.
Great. And then while that's going, are there restrictions on types of piping material that rug can be used on, or limitations on the type of substance contained in the pipes?
For the pipe material, it would just have to be ferromagnetic. It would have to be something that our magnets could stick to. And so, primarily what we look at are carbon steel pipes, although we do also do work on things like 2205 duplex pipes. So, the only limitation would be, can the robot stick to it? And can you collect UT readings on it as well? And Sam, I'm sorry, I think there was a second half of that question as well that I'm forgetting now.
Just wondering as far as the limitations on the type of substance contained inside of the pipes.
Yeah, no limitation that I can speak to directly right now. If there was a specific substance that you wanted us to evaluate, we'd be happy to do so. But certainly the robot can be used on pipes that have hazardous substances in them. If there was something specific though where you had particular concern, we could always have that discussion with you and talk about it with our engineering group to make sure there'd be no specific concerns with that substance.
Are there currently any limitations in the robotics technology for inspection of pipes?
Well, yeah, and I think we talked about some of those limitations already. Obviously there's sizing issues. For rug, we need to be 6 inches and over. For AUT, we need to be 4 inches and over. And so, obviously that's one limitation. The other limitation would just be certain types of obstacles might require the use of something like a JLG or limited amount of scaffolding in order to traverse those obstacles. If it's something that the robot can't climb over, we need to move the robot past it. And so those would be the primary, I would say the primary things that I would think of in terms of limitations. There's probably more than that. Like I said on the previous question, if you have something specific in mind, do feel free to let us know. We'd be happy to look into any specific situations where you think there might be concerns. But that being said, most piping circuits have obstacles and have challenges because most piping circuits are, they're running far above ground or they're twisting and turning, they're going inside buildings. And so these are challenges that we are very adept at solving and very used to solving with our technology.
What's the max length of the cable? Is the robotic platform tethered only or also available in wireless versions?
Yeah, the robotic, so the rug robot is tethered. And the reason it's tethered is because we need to provide a water source to it continuously because we use water as the couplant for the UT readings. Now, as of right now, we can go about 300 feet from our base station. And so our base station includes a water pumping unit, includes it includes the power source and everything like that. And so we need to be about 300 feet from that. And so for piping runs that are much longer, where we need to get further than that, we would just need to reposition in between in order to get the next section. But the 300 feet is usually going to give you quite a bit of reach and get you a lot of the way with most piping circuits.
Can you explain a little more on how the software calculates the future condition of pipe based on corrosion rates?
Yeah, so it's going to use a similar calculation to what you would see in API manuals, for example. It's going to take the original year in service, the original nominal thickness, or a baseline thickness that was taken, and it's just going to perform a regression analysis to create the future potential wear. Of course, there's also opportunities for us to add in more complex calculations to that if there are specific needs that require it. But typical corrosion calculation that we're doing is just going to be in line with what you would see, for typical API vessels and things like that.
How fast in square feet can rug and AUT move?
Off the top of my head, I don't know the answer for AUT. It's going to be a lot slower than rug. Rug can do on a piping circuit, it's going to depend on the size of the pipe, but just as a, decent approximation, when the robot is actually moving, you can cover approximately 1 foot by 1 foot every second. That could scale up or down a little bit depending on the size of the piping. As the piping gets smaller, the array that we're using is also going to get smaller. And so it might be a little less than that. But a good rule of thumb to think about here is, we can, in a single day with rug on a typical pipe that's say 10 inches and under, we can potentially do 100 to 200 feet per day with the robot. Sometimes we can do much more than that. It really just depends on the obstructions that are in the way, how many times we need to reposition the robot. If it's just a straight run 100 feet out, that's a lot easier than if you have to reposition the robot multiple times along the way. For something like a digester blow line, we can perform on a typical batch digester with a blow line, we can do about 1.5 of those per day. So, if you have 10 digesters, you can do the math there, figure out exactly how long it would take to perform a full inspection on those. And that's all with one robot. The other thing that I would mention is if you have time constraints, we can bring more than one robot and more than one crew. So one crew is typically 2 men and 1 robot. We can increase the speed of an inspection by sending multiple robots. So if you have a time crunch where you need to get an inspection done in a day or 2 days as opposed to 4 or 5 days, we can perform that inspection faster by sending 2 robots instead of 1 or 3 robots instead of 1.
Great. And then last question here. Are the robots intrinsically safe?
I don't believe that they are, no. But I would have to check with the engineering team on that because I know one of the robots that I'm showing here is a newer robot that we've only recently released. I'm not sure if that one is or is not, but I believe the answer is no. I can certainly circle back though and confirm that.
Great. And then one last question just came in. The rug tether, is it also providing power to the unit? And then does rug use external power supply or battery powered?
Yeah. So the tether for the rug robot is providing water, power, and Ethernet to the robot. So it's doing a data uplink there. It's also got your power and your water coming through it. We typically use site provided power and water, although we do have the ability to operate the system with generator power and with water tanks. If if a piping run or a tank is in a remote location where it's difficult to get a direct connection to a site water supply or a site electric supply, we can bring our own as well. So it's really going to depend on the specific conditions at your site. But typically it's site provided water, site provided power that hooks into our robot base station. And then our robot base station provides power and water up to the robot through the tether.
And then does dirt and dust on pipes usually cause any slippage issues or compromising operation or speed?
No, not usually. If you have an extremely dirty surface, it could make the speed of the scan a little bit slower because we might have to run multiple times, for example, to get the data that we want. But under typical circumstances, even with a little bit of surface fouling from dirt or dust, our robot can read through that and can still gather data in a lot of those circumstances. So, the quick answer is no, most likely it won't cause a problem. If you have a surface that has, caked on mud or caked on dirt or scale of some sort that's, very thick, that could cause a problem. But that would be something that we could assess with you prior to performing work on an asset. If it turned out that surface fouling was going to be an issue, we can make recommendations and also have cleaning companies that we work with to get an asset ready for a rug scan.
Great. And then are there any issues obtaining readings on piping with internal scale?
No, there shouldn't be an issue with that. We can deal with issues like internal scale without having problems getting readings. Now, the readings that we would get would most likely be the metal thickness. We would not necessarily be getting the scale thickness. So that's something to keep in mind. If there is that internal scale, we would most likely not be giving you the thickness that included that scale. It would just be the thickness to the back wall of the actual pipe itself.
Great. That's all we have for today. But thanks everybody for joining us for this webinar. This will be recorded and also sent out to everyone. And then if you do have any follow-up questions for David, David, if you want to put up your last screen there, please feel free to reach out to him. Otherwise, thanks for joining.
Thanks, everybody. Appreciate it.